All right, so good morning. Um, Glad you all made it here safely. So today is going to be our third tutorial, and it's going to be on drivers. So before we get in, I have to remind you all of a big event coming up, as requested by Dean. Oh, that's shouldn't be that color. Hold on. Here we go. The Land War 2.0. This is going to be on March 1st in UB 2080. It is a partnership between NetSoc and the GDSA. And so NetSoc is bringing Land War 2.0 to campus. And you can join them for the full day of LAN gaming, friendly competitive matches, and casual games. Whether you're playing, watching, or just stopping by, it's a great chance to connect with other students who are into gaming and tech. And there will be prizes for the competitive players, and they must sign up using this QR code right here. And then you can see the date and the time and the place. And we also have the competitive bracket, which is these are the games that they're going to be playing for that. And then the casual bracket over here, it's a little bit smaller. And yeah, so if you want to be part of the competitive side of this, you have to sign up here with this QR code. And you can also find this on the slideshow. So let's get into today. Just make sure my audio is good. Double check. Good. Can't be too sure. All right. So drivers, what are these? This seems like you might be confused. You might be thinking, oh, drivers as in someone behind the wheel. No. Drivers are a very cool thing we can use in Blender to improve our way of interacting with different rigs, animations. And without me having to just explain it all right now, you can just watch this. Wait, where's the video? Hello? Oh, here it is. So before I even explain anything, I want to show you this video.
Using drivers is a really efficient way to control any property in Blender using mathematical expressions. Let me show you how we can use this powerful tool to create something that looks simple but has a little bit of magic under the surface. So let's make a cube. Shift A to make a cube. I want to twist this cube. So let's go to Modify Properties, Add Modifier, Simple Deform. Set it to Z-axis. And let's move it on the z-axis by a value of 1, so G, Z, and then 1. If you twist this now, it's like sliding around, so you can right-click and set origin to 3D cursor. So now this twists beautifully. Here's what we have done. We have made a cube, and we have given it a subdivision surface modifier. We have given it a simple deform modifier set to twist, and the axis is Z, and then a simple deform modifier set to bend, and on the x-axis, and then another subdivision surface at the bottom to just make things a little bit smoother. Now you can take the bend modifier and you can move it up and down, and you can take the twist modifier and it will go sideways. So this almost looks like this is looking around, and we can use drivers to easily control this. So let's reset this to 0 and 0. Shift A, and let's make an empty object, and let's press F2 and call this driver controller. We want to work with like whole values, so I want to place this 2 meters on the y-axis and then 2 meters on the z-axis. I want to use drivers to twist this cube based on the position of this empty object. So let's right-click on this line and go vertical split, and let's set this to drivers. So now what you want to do is you want to take the cube under angle here, you can right-click, add driver, and there's a little menu here that just shows up, but it just goes away if you move your cursor away. And you can keep on editing this driver here, but it's also just as easy to just click on the driver and then click on this little keyframe sort of thing. And then when you press N and bring up this panel, then you can press the driver. It's not a keyframe, it's sort of like a link, which is really cool. In the driver property, let's go to object and let's place this on the driver controller. You can see this is mapped to the X location. So now if you select the driver controller and press G and then X, this will rotate because it's quite conveniently used on the x-axis by default. I would like to have it a little bit geared down. It's too strong, Select the cube, and then this is the expression. The amount of distance this moves on the x-axis is called var, like variable. And then the expression is variable plus 0, so you can get rid of that if you want to. And then you can just multiply it by 0.5. So now when you move it, it will move half the speed. which I think is a little bit better. Now we want to link the bend to the z-axis. So let's do the same thing. Let's right click on the simple deform modifier, add driver. Now let's set object. Let's take the little eyedropper data block and let's place it on the driver controller. Now you can select this empty and you can also move it on the z-axis. Or I mean on the x-axis, but we want this to be on the z-axis instead. So select the cube and change the type from x location to z location. So now this goes crazy, but that's because this starts at 2 meters. So let's set the variable to variable plus 2. No, that's minus 2, I think. Yeah, perfect. So now we can move this up and down, and we can move it sideways. Now we can move this, and our cube is looking around, and it's being controlled with drivers, and this just plays extremely smoothly. It's an incredibly powerful way to just start animating stuff. That's how you can use drivers to convert motion or rotation or scale or any value from one object to any other value. For example, the angle of the twist in the simple deform modifier.
Okay, so yeah, thank you. Yeah, the video, I love that video. When I was doing this whole, setting this all up, I thought it was very fun just to see what it is at a glance. How's it going? Definitely a bit overwhelming at first. You're like all these different new menus and everything. And why is the values purple? That's kind of weird. So I did go through the slides in a bit of the wrong order, but here's the Blender definition of what a driver is. Drivers are a way to control values of properties by means of a function or a mathematical expression. And that's like, what? So my definition is drivers control one thing's numbers with another thing's numbers. So this thing moves, the other thing moves in a different way. That's how I like to think of it. It makes more sense to me. And then that was the video. And so drivers require some math. To make it simple, what you change on the x value, so you can think of this all as a graph, right? What you change on the x value will change what happens on another object's y axis, y value. And the axis affected can vary on your choices, right? So some common examples of some numbers we might want to use, or yeah, for example, would be, we know our different formulas here, right? A lot of time we'll be using maybe something like a slope value like this, where fx equals x. And so it's just kind of like a linear curve in one direction. And so this would entail that when I move something along this x-axis, then we'll have some changes, some positive changes on our y-axis, right? Things like that. And so our driver editor, there are 4 main areas within our driver editor that we need to consider. First of all, we have the target to be driven. So this is the value that we're changing. We have the graph editor itself, which is where we can see the visual information of what is being changed along those x and y axes. We have the driver window itself, which is where we plug in our variables that are actually affecting our driven object. And then we have the modifier window if you want to add some more unique formulas as you saw here, right? So this stuff you can add with modifiers, right? So starting off, by the way, today might be a little bit of a shorter one just because of the kind of content this is. It's pretty easy to get through. So first of all, we have the target, which is the driven object. And so this object is the one that's being moved in this case. And so purple means a driver is controlling that value. And so in this example here, we have this is like an iris and pupil blend shape key. And so when you change the value, let's say of an empty transform or some sort of bone, if you move it up and down, for example, you might bind it to 0 and 1 on this value right here. Next is our graph editor. This is very useful for visualizing our movement of our different drivers that we're making. And so, as I said before, we have our x axes, which is the controller, the driver. And then we have the Y value, which is the target, the driven value, right? And so I always get confused when I'm setting drivers because when I set the driver to the driven value, and so I'm always like, okay, the target is the driven one, but you're adding a driver to the driven value. It's a little confusing for me at first, but once you understand that anything you change on this y or this x-axis is your driver, and then anything on the y-axis or x-axis is driver, and then anything on y-axis is the driven value, it makes more sense. And so the driver window, this can be found in the drivers tab or by right-clicking a purple driven value and clicking edit driver. And this is the place we add controller objects to drive our target object. And we can change the type of transformation and the math expression here, right? So you can see we have, for example, these are the modifiers for that cube, which is probably something we're not going to be doing for rigging, but that was just a fun example. If you right click on that whatever slider value you want to change, you can then add a driver, or in this case, since it's already purple, it says edit driver. And so once you click that, then you will have this driver tab here pop up. And so this is in here, we can see that we have a driver affecting it. And then we have it's a scripted expression. And so our expression here is var, at least in this case, is var minus 5. So it's whatever variable you have changed in the driver value minus 5, right? You can change this to whatever value. And so here is the cube itself that's driving this other value, right? And you can see you can set the type to X location. So wherever you move this cube on its X location will be that value that's being tracked. And I set it to local space as well. So it's not bound to the world space. And lastly, we have modifiers. Modifiers for drivers. This is the most technical part of drivers, but I'm not too sure how much we'd use this specifically for rigging, but it's good to cover regardless. Modifiers are useful for adding complex mathematical equations, generators, built-in functions, noises, etc. to our drivers itself, right? So instead of having it be a one-to-one relationship, as I'll show in these examples soon, you can see that we can bind a sine value, for example, to time to have some sort of back and forth motion, right, type thing. Or we can have just random noise, which gives us really cool results, right? And so I left in the slideshow the documentation for the simple expressions that you could type into here, right? This is where you type in all those expressions. So here's a link to that. And then complex expressions using Python. Just some of these that can help if you want to know like more complicated math equations you can plug in. And so I did say this was going to be short, so now we're going to get to our more hands-on part. If you want to join in or just want to watch, this is the build on section where we explore drivers like with our actual eyes and our mouses. So drivers for rigging. What uses do drivers have for us in this class? Drivers have 3 core uses. In our case, we have the drive shape keys, so we can drive those. We can drive bone data, such as the location, the rotation, the scale, and we can drive object data, right, such as maybe some Bezier curves and whatnot. Even with these 3 core uses, the way we approach the driving through our expressions is pretty limitless. And I only am going to show you just a snippet of ways you can use drivers. I've created this fun interactive way to see drivers in action. It is found in a canvas. If you would like to download this blend file, I can show you where it is right here. me just go back to student view. You can see under week 3, there is the driver showcase into rigging week 3, 2026. And so if you download this and then open it, we'll just do that. I did make this with Blender 5 so that if you have any issues with this, with opening it or with interacting with it, that could be a reason. And so here we have a few examples of what drivers can do for us. Some of these are very relevant. Some of these are just kind of fun to look at regardless. So starting off, if we go to the very left here, you can see that cube that we saw in the video. I decided to recreate that just for this example. So in this case, we are driving modifiers with the transforms of this right here, right? So this is not as useful for rigging, but it still has its merit because we can see that when the interaction between this transform and the modifiers of this object right here, right? And so if, for example, we had something like an armature attached and it's maybe weighted to a cube or something, we could use drivers to manipulate those modifiers within as well. Yep.
So since these drivers are like in the software, is there any way for these to get like exported to engine, or are these pretty stuck in Blender?
So drivers are only bound, to my knowledge, within Blender itself. It's a way you can animate across different objects or different parts of your scene pretty easily. Drivers are just connected to everything within the Blender project itself. And also it helps speed up the rigging workflow because you can sort of do more technical things, and such as I'll show you, you can have like blinking eyes using drivers in a way that's very kind of hands off, where you have this UI element and you interact with the UI element, which is your controls. But that I don't believe that you can transfer it into Engine.
Yeah, so you do the blinking in Blender for the animation so that's used back in the engine.
Right. So whenever, like in general, whenever we're exporting our animations from Blender, it's usually just the armature with the deformation modes and our weighted mesh, right? So we're never going to be exporting our mechanism bones or control bones because that's one, it's too many bones, and all that the engine cares about is the deformations, right? And so all this is just fluffing up our ease of use for making rigs and animations, right? And you can see I made sure in this blend file to provide I opened the driver tab here. And so you can see in here, it's pretty similar to the timeline. Like it looks pretty similar. If I click on the cube, you will see something appears. And so if I just frame selected here, right? So I clicked screen keys are on. Underneath escape, I can frame selected. You can see here this interaction that I was talking about. So everything along this axis right here, this is the transform of this it's transform of this empty right here. So I can lock, I'm gonna lock this here so I can select, here we go. You can see if I move this 1, you can see here we have a visual representation of what happened. So I moved this transform by 1, and you can see it's mapped right here, which is 30. And what does this 30 mean on the y-axis? This 30 represents the angle, or 29.6, the angle that was displaced on the cube here, right? And you notice there's also this second line here, this green one. This one is bound to the z-axis, right? See, every time I change it, this value here is changed, right? So right now, if I set this transform close to 1, our value for the upwards bend on this cube is close to 60. You can see right here. Right? So this is just helping you visualize what's going on with drivers, and that it's just a link between two values you set, right? And so in this case, I did add 2 drivers, one for the twisting and then one for the bending, right? Any questions so far? Super. Okay, so this one is more of a fun little thing, and now you have it to kind of play around with. Next is one that's a bit more, or much more, procedural. This is time-bound transformations. So this object here is bound to the timeline. So you'll notice when I start to drag the timeline like this, it starts to spin in a circle, right? You're like, how is that happening? What's going on? Let me just turn that off. I can pin this here, and then I can check the X location. There we go. So we can see that as we move the timeline, as you scrub the timeline, you'll see that it just oscillates like that, right? And you're like, where's the X location? It's up here. Oh. You're like, how is that happening? Right? So if we check here, we can see that in our driver window here, right? It's under animation drivers. We have the F curve, which this is just a manual way of setting this line here, but we don't really need to worry about that. What we want to look at is this expression. So this is a custom expression that takes our frame and then it divides it and then multiplies it by cos and then multiplies by 2. The important thing is that it sort of just constricts that value in between the 0 or -1 and, or like between these two values here, right? And so our X has a bit of a different one that uses sine, right? And so when you combine the cosine sine like this, we get sort of a circular motion, right? Where you can imagine we have one of these just kind of oscillating like this only, and then another value oscillating this way, right? And because they are doing it at separate or opposite intervals, you can get that circular motion, right? So this one's definitely a bit more technical, but it's cool to see. And you can now have the expression to look through. Next up, we have sequence movement. And so this is a way that you can sort of chain different blend shapes together, or just see how your transforms of a bone can influence the blend shapes of your object, right? So you can see here, this cube has the basis, which is just the default state, and then a key 1 and key 2. And then there's a bone here, right? And to interact with these bones, we could either just go with, like in this case, we can just interact with it in object mode. But you could also interact with it in pose mode, which is probably ideal because we want to be using pose mode when we're interacting with bones no matter what. But you can see that the blend shapes here are being adjusted or changed based on what we're doing to this bone. And so if I click back on here, you can see, I don't know why there's a pin I can't use, why there isn't a pin, but you can see that these values just infinitely move indefinitely. You see here, this line is just infinite. But because blend shapes are only bound from 0 to 1, it's going to stop at 1 no matter what. It's like a clamp, right? And so if we move this, you can see here, if we move this bone here from 0 to 2, 2 being 2 meters on the z-axis, you can see that in here in the driver tab, variable armature 05 bone, z location, world space, right? And so as we move it 2 meters up, then our bone or our blend shape reaches 1. And so that's when it stops moving. But you can see here there's a second shape key, which as soon as we reach 1 on that first shape key, this one leaves the -0 and starts to climb up to 1 itself, right? And so you can see right now our value is here. This is where our current bone value is. If I move this up, you can see now it's up here, right? So it's just a good way to visualize what's happening at the level here, at the driver level. And that one's really cool. And so this one is my favorite. This one is a way you can control very small, fine details such as eye movement with drivers in a way that's not super like hands-on the model itself, but you can sort of interact with it further away. So controller driving bones. So what we're doing is we're taking this controller that I created for this example. You'd probably use a bone that has a curved object as its visibility, right? But in this case, I just use a actual surface object. You can see here, this eyelid controls the opening and closing of the eyeball right here, right? And there's a few things happening here. You can't interact with this circle here. This one's just stuck. It's just for visual. But then you can also just move the entire UI element here, right? So you can see that when I move this entire thing, it's not changing this opening and closing of the eye because this curve is only, its transform is only based in local space. So it's not world space driving. You can see in here, there is this bone, these bones. Let me just make the visibility in front. So these bones here are being driven by this eyelid. You can see that right here. And so if I control tab into pose mode, if I click on either one of those, you can see in the driver tab that we see this Euler rotation up here. for each of them. And so what I set for each of them is this one, this top bone, will, based on, you can see here, the Z location of control eyelid, which is this right here, it will, on the local space too, so meaning if I move this entire object, it won't move. Only when I move the object itself does it open and close. That affects the rotation of this bone. Oops. And so if I, oh, there we go. My frame selected, you can see here. So you can see there is this line here, and you see sometimes it takes a while to update. I'm not sure why, but as I move it along, it changes where it's interacting with, right? And so because this transform here, it's already offset by 1.2 meters from the origin, the Z origin, I had to add this offset 1.2, because if I didn't, the eyelid would just go crazy, right? You see it's behind it now. So if you have your control not at 0, 0, 0, and you want to make some sort of location-based effect, you'd probably have to offset it like this. And the bottom is very similar. You can see, where is it? Yeah, so this top one is the X Euler, and then the bottom one is Z Euler. Right, and so it's very similar, but the main thing is, actually I think they're just pretty much the same. Based on the way I made the bones, it just kind of opens up, it blossoms open, right? But yeah, drivers are a great way to interact with those bones without having to, let's say, go in here and manually pose it ourselves, right? But because I set the driver already, you see I can't rotate it along the x-axis while it's the driver set. But this saves us from having to manually use control right in front of the bone, when we can just, because eyelids will only ever open and close in one way, we can just use this to do it, right? And so I'd say one of the most powerful ways we can use the drivers is with deformation correction with shape keys. So there is an annoyance when you, let's say, are having a limb that's bending in your rig, where a lot of that mesh just sort of scrunches up in areas, or it stretches too much in another area, and it looks pretty ugly and just not good for what we want in our rig. And so also when we bend certain parts, like our bicep, for example, we'd expect a little bump to appear where the bicep is constricting, right? And so that's what this driver is doing here. So you can see as I close it, or as I bring the bicep in, that shape key fully activates, right? But at the same time, you can see if I move up close, you can see that there is a shape key also here. There's vertices here that are also being affected by the shape key, right? And if I showcase, so the geometry looks like this for this arm. You see it moves a little bit. So if I go into the hood here, if I click on the actual, because the driver, we are driving, it's kind of weird. The driver values are set on the driven object. So I have to click on the actual arm itself to see where the driver is. And so also, if you don't have this menu open, right, which usually in your Blender scene you wouldn't, you would just have the timeline open. You can right click on it and edit driver, and then you can see just this tab here. And if you wanted to see this entire view down here, you can just click show in driver editor and it pops it up. Though I prefer just to instead, let me just, oops, oh no. Oh dear, I actually created an extra tab. There you go. So your usual Blender scene would look like this, right? And so I can just go to the corner of each side, and then when that cross appears, I can just drag to split it, and then I can click on this clock here to add a driver. You see? And so now you can see our bicep keyframe or shape key here. And if let me just select all this, frame selected, so there we go. Now we can see that this is the motion that's happening, right? And so this was done manually instead of setting it with math in here, right? You could set a very complicated expression, or if you're feeling just like dragging these curves yourself, right? If you're planning, hey, I want when the arm is fully extended out to be at 0, to be unactivated, you just set the first value at 0, 0, like that. And then let's say I want my bicep to be fully engaged halfway, right? So when my arm is like this, my bicep is at its peak, and then if I keep going, it'll just stay like that, right? So the shape key is activating in between 180 degrees and 90 degrees. Yep.
I'm just curious what made the bones red.
I set it to red.
Okay.
Yeah. Well, I think it's like a deep orange, right? I guess I could show that as well. So here's a little side tangent. You can set the bone color in the. So if I go into if you go in pose mode, and then if you click on the bone here, there's viewport display, and then you can see, so display as 1, so you can change each bone to a different, so each individual bone can be its own object, right? So by default, it's all going to be armature defined. But you can see here, we can change the bone color, or we can change the bone pose color, right? So only when I am in pose mode does it change color. And so that's a good way to color code your model instead of having, if you don't want to check the name every time of what you named it, you can just look at the colors and know, okay, this is my control bones or my pose, my deform bones, whichever. But that's a way you can do that in here. Just do, there we go. Yeah, and so when we are taking our arm and we want to have our 90 degrees at full bicep peak, you would take this other spline here. So I think by default it looks like this, right? You would just click on the value and then find that part of the curve. And in this case, I want when this value reaches, let's see, undo. Let's make sure. Yeah. When it reaches close to 0.75, you can see here that our blend shape reaches 1, right? So anywhere at this point is where it reaches 1, right? And so we can drag it. We can drag the different handles to create a very custom motion, right? And so now I believe I made it much quicker, a much quicker bicep curl. Yeah, so now it's curling about there, right? But I want it to curl here, so I'm going to set the bone there. If I go back to the object mode, you can see, oh, no, I can't see it. Oh, you see it right up here. This is where 9 degrees is set, right? So it's at 1 on the x-axis. So I just got to move it like that. Right, and so now, hopefully, we should have a very smooth blend when we curve this arm now. You can see here. Nice and smooth. Right, so that's good for obviously your arms, right? But if you have other muscles, for example, that you want to have your character flex, right? You can use this combination pretty well, right? And so the bone, the reason why I highlighted this bone as that deep, deep orange was because this is the driver bone that's driving the blend shapes, right? And so it is the rotation of this bone along its, I believe it's, yeah, x-axis that's directly affecting that blend shape key, right? So that's really fun. And last but not least for these examples, there is, let me just turn off the wireframe. There is the chain additive rotation. So this was an interesting example that I decided to add for this showcase. So this is great for a sequence of bones such as fingers that all curl in one direction. Usually, I'm sure you've tried to select multiple bones on a like all parented together, and then if you rotate it, they'll all curl together. And I'll show you exactly what I mean here if you haven't. So if I go into pose mode, select the orange bone, and I rotate it, you can see all the other bones are all rotating in the exact same amount. You see? So I can even rotate it over and over again. It's kind of a fun pattern. It's a really fun pattern when you get close and see it here. But yeah, this is something you can do. You can do this manually. If I let's create a bunch of bones, right? And I go into pose mode, and I click and then I do individual origins. It's the exact same effect that happens, right? Because you're rotating every single bone on its own local axis, right? Versus if you just selected the first bone here, it's only going to rotate on that bone only. Everything will just keep the same transform, right? So instead of having to select all the bones at once, this driver alleviates that through copying that transform to the other bones in the chain. Yeah,
that one is,
absolutely.
It all has to be the same.
It doesn't have to, right? So
Will that
in this case, yes. So that's what I set the values to. I'll show you what the values are. Just delete these. So if I go back into pose mode, where you can only also set drivers in pose mode for bones, it's a pretty much a one-to-one relationship. You see? Yeah.
I mean, like you could change that one, but like if you're doing it rotate by individual ordinance, that one's rotating on every single day.
Exactly.
You're not using a driver, obviously.
Right. So what I could do, so all these bones have a driver, or yeah, they are being driven, each of them, by this one bone here. So let's say I want the final one to bend much faster. I can set the variable to something like, I don't like to edit the expression here. It's a bit more tedious. I like to visualize it in the actual driver editor here. So I can just drag this up. So right now it's set to, at 1, it's set to around 60. I can just set that to like 120, for example. And so now you can see that bone is moving much faster. Or I can even move it up a bit more. Yeah.
I can see what the reason for using a driver for this is, but I mean, isn't there the copy rotation modifier that would theoretically do this except for command?
Yes, and exactly. However, you can see here, there is, because we have access with the drivers to the curve editor, instead of just copy rotation where it's a one-to-one relationship, where when I move this hand, this other hand will move the exact same amount.
My question isn't why use the drivers, it's why use the modifier.
Oh, why use the modifier? Because it's easier. It's much faster to set up. So if you do have like a one-to-one relationship for things, you can just use the copy rotation,
Okay.
and it's much faster. And this is much more complicated for a reason, right? Because you can do things like, you can have a curved sort of effect, right?
Okay, so it's just complexity.
It's complexity, yeah, right. The constraints are, if you want to make a relationship between two bones, try constraints always first. If it's a little more complicated, then drivers are your second choice, right? Yeah. And so you can see here that because I set this bone's driver to a much steeper value, it rotates much faster. Right. Really fun. And also, I forgot to mention, for this cube here, there's a little something hidden in the very end of this graph. So if it's zoomed out a lot, you can just select everything, and under escape, if you hold that, you can frame selected. You can see I just kind of have this angle shoot straight up with the curve, right? And so you can see when I move this cube along, eventually it just kind of spazzes out, or it starts to freak out more. That's because it's passing that threshold and it's starting to just straight up into infinity, right? And that's the kind of fun tweaks you can get with this. Another one is, let's say I want to go into this cube again, and then I can add a generator. Let's see. Oh, I turn them off. Here we go. So there is the first one that I decided to try was a polynomial, expanded polynomial. So right now I have it's a order of 3, and so you'll notice when I bring it to each direction, it goes rapidly, like it's really fast here, and it starts to slow down, and then it starts to speed up again, right? And that's because this value is following this formula here, right? And so that's all procedurally done. I can change it. I can, let's say, add a 2 or a 1 value to the x to the power 2, and then a 0 here to get our favorite curve here, right? And so now it kind of does a ping pong. You see? So much fun you can have with this graph. And then another one is there is this built, so I left under this cube as well, there's a built-in function. And so in this case, I put it as sine wave. So let's see, is it working? Did I turn it off? Yes, I did. So when I move it now, it kind of oscillates back and forth. So I can set the height of it, so the intensity, the phase multiple, so the amount of waves, you can say frequency, and then the amplitude. And so now when I move it like this, it sort of does this pattern here, right? And it's not necessarily this movement, these modifiers that we're sort of eyeing for what we can use for rigging. It's more of these sort of patterns of movement that we can figure out how we can use in our rigs, right? I don't know exactly when you can use oscillating like this, but it's just fun to know that these things are possible with drivers. And then the last one is noise. So noise, if I just set everything here to 0, it's what you expect, where it just is random transforms, right? So this is some very specific example, but maybe you wanted to make an old man, and then you wanted when you move their hand to have like a sort of tremor, right? So you can have it like not that intense, but you can have some sort of tremor from moving the object itself, right? Something like that. Okay, so yes, yeah. You can control both in the same driver, absolutely.
Would it be beneficial to have a driver, like a parent driver that does both, and then also individual ones?
Yes, exactly. So ideally, when you're setting up the actual drivers or the controls for the eyes, you're going to be having, I'm sure you've seen it, like the goggle thing, the goggle curves where you have the main one, which is the mask, and then the two eyes inside. So that mask kind of acts as the parent driver, where wherever you move those goggles moves both of those eye controls together, and then you can control each eye specifically within that goggles that you create, right? So it's about finding what works for your rig, and I think using both separate and a combined driver is the best thing you can do for eyes, right? Because when you're looking at things around the room, your eyes are both being fixed to a specific object. So you can have, let's say, like a look at uh, constraint, right? Where you have this object somewhere, and then both those eyes converge at that point, right? Things like that. But then you can have the individual eyes you can move if you want to have a lazy eye or something, right? So that's it for these examples here. And what I wanted to do to sort of try one to make one ourselves is work through this driver problem here. So you can see that when I move this cube, it moves the other cube with it, and it also moves up and down. So right off the top of anyone's head, can they guess what's happening here? Yeah.
My guess is that one X and Y has been linked to the smaller cubes I guess, x-axis. I don't remember which one that actually is. So I'm just going to say x.
Yeah.
But the y is specifically set to a generator of sine or cosine.
Yes, exactly. Oh, but in Blender, remember the up axis is the Z axis. In Blender only, though.
I don't know.
Yeah, it's okay. It's kind of confusing with certain engines that have different ones, but yeah, it's X and Z, right? And then the Y is just on like the forward and back, which is kind of confusing. But yeah, exactly. That's what's happening here. So we're gonna recreate this. If you want to follow along, you're more than welcome to. So I am going to I'm gonna shift and then right click my cursor so it's over here, just away from everything. And I'm going to shift A, create a mesh, create a cube. And I'm just gonna actually snap my cursor. Oh, whoops. Cursor to grid. Nope, not there. Here. Push it to grid. I'm gonna snap my selection to cursor. So now this is on the actual grid. And so what I'm gonna do is I'm just gonna move this up 2. And I'm gonna shift D, duplicate this to negative. So it's right there. And then if I click tab, go into edit mode. I'm just gonna scale this down 0.5 or maybe another 0.5. That's 0.5. So if we go into our collections here, I want to make sure this is all organized. I already did collections for everything else. So I'm just going to click new and then rename this driver or this collection to driver example. And then just drag, in this case, it's only these two. I'm going to put those in there. Where's this plane at? Oh, it's that. And so because I want to be able to differentiate them, I'm just going to give, you don't have to, but I'm going to give one of these a color, material color. I already have some materials created, so oh, my Blender froze for a sec. 1 second. There we go. That was annoying. So, oh, I think it's kind of messed up now. Oh dear. I'm gonna restart it quickly. I don't know what happened. Here we go. Okay, so I have these two cube objects. I'm gonna name this one because naming is important. I'll just call it control for this example because that's kind of what we're using it to do. Control cube. And then this one could be, let's say, I'm gonna call it just def cube. It's the one that's being deformed or controlled. Right, so the controller and then the deformed. And so what I'm going to do is I'm going to click N to open the transform tab here. And I'm also in object mode just to make sure. I want to decide which axis do I want to move this cube on. I want to do X. So right now the X is set to 47 meters. I'm just going to right click it and then add driver. And so it's going to create it in this driven property tab appears here. And so you'll see right away before we even do anything, it set the expression to var plus 47. So it's offsetting it from world origin because this cube is already set from world origin, right? And then it also has input variable, which is right now it's set to blank. And so what we can do is we can set this I drop the object. And you're like, what happened? Where did it go? We can see the transform is now 94. So what's happening here, you can see the cube is way over here. If I go into the driver tab here, we can see we have this linear relationship, but that's not what we want to look at right now. We want to look at the actual driver properties here. And we can see that our cube is being offset by 47, but then our actual driver cube is also offset by 47. So it's just adding those two together to get 94. And so there are a few ways we could alleviate this. The first way is to just set the var to just var. And so what that's going to do is it's going to, whatever this value's x is, copies it directly to this value's x. But sometimes you might not be able to do that. There's another example where you can set the space of this cube from world space to local space. Oh, unless I'm wrong. Huh. Or actually, this would only, the local space would only matter if this was, as it says here, if it was parented to something else, right? I believe. So let me try that, for example. To add an empty. That's parent. Child, parent, control P. And so now if I click back on that cube, I guess it's not working that way. But what we can do is we can just remove that 47 to align them back up again. And so I'll just remove the parent for this. Right now it's bound to the same axes here, right? So when I move this cube back and forth, it also moves this cube back and forth using, see, it's 1 to 1 exactly. So 1 meter here moves this one 1 meter as well. But we also wanted to add that oscillation up and down with sine wave, right? And just because I don't want this cube to kind of move anywhere it wants, I'm gonna lock the y and z, so I can only move it on one axis, right? And so I did that here. And so now, if we go back into our driver tab, we can see this modifier tab here. We can add a modifier, and in this case, I'm going to add a, I believe it's generator. No, generator is for making different polynomial curves. Built-in function is what we want, right? So we have all these different functions. We have sine, cosine, tangent. That's a fun one. That would be crazy. Square root. Natural log. Normalized sine. Right? So right now we're just going to do sine. And you'll notice right away something happens. Where did it go this time? Oh, it's just affecting the x-axis at world origin. We don't want that. What we want is, one, this cube to be going up and down on the z, and also not to be at origin, right? And so to do that, we can't just add the modifier to the driver we already made, because that one's only affecting x. So we have to remove that sign. And then instead, we have to right-click our z-axis transform and add a driver to that, right? And so now, if I go into the drivers tab here, we have this new line that we can interact with. And so right now it's set to var plus 2, so that's the default offset. If I set the object to the control cube, oops, this control cube, it's going to disappear again. And that's because right now it's set to X location, world space. So that value of X location is 47. So it's just kind of shooting this up 47 meters upwards. We don't want that. We want to set the type here to Z location. Right? And you can also notice that there's already still this offset that we don't want. So we can just remove that plus 2 to bring it there, right? And so now we can move it forward and back, or left and right, and up and down, right? Pretty similar to parenting, pretty much parenting the object, but in this very technical way that we can use curves to manipulate. And that's what we're going to do right now. So I'm just going to lock those two axes again, or not on that part, on this cube here. And then back into the main cube, we're going to go to modifiers on the Z location, add a modifier, and we're going to add the built-in function, right? And now you'll notice, if set properly, you'll see this, now the Z location is just up and down oscillating. I gotta make sure to, wait a minute.
Set to the wrong axis.
Oh, is it? Oh, you're right. Oops. Yeah. So we actually didn't need to change, thank you. We didn't need to change it to Z location. We need to change it to X, right? Because our X is still affecting, when we move it along X, we want that to affect this cube, right? But what we did was we set it to the Z on the actual cube itself. So the cube is, whatever movements we make here is affecting the cube's Z, right? And we can do things such as adjust the phase multiple, amplitude, offset. So I can just set this to 2. And then now we can have different effects happening here. I can get nice and long, but short, or I can just stretch it out, right? This is a very fun way to get some very interesting results. And then I could even shorten this down, add some noise, scale it down, and then maybe make it more intense. Oops, this one. See, get some fun results. Drivers are cool. I like them. And yeah, so that's it for the driver problem. And that's it for what I am teaching you today. I give you now the floor to work on your weekly activities, or if you need to go now, because it's still really early, you're more than welcome to. But thank you so much for your time. And as we move on into the future, we're going to have probably some more specific, detailed labs. And then in week 5, so in 2 weeks, will be the first activity, which I will give you. It'll be released during the class time, but then you'll have a couple days afterwards to finish it on your own time. So you'll have that time given to you for that. And it'll be posted soon so you can see what the content of that is. And yeah, now it's the time for you. Thank you.